Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have the questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I respond as soon as I can. All right, so today we're going to be reviewing for the Chapter 11 test, which is due no later than 11:59 tomorrow night. Then over the weekend, you should study for the final exam. On Monday during class time, we will have open questions, anybody that wants to join to review for the final. And your final exam is on Tuesday, due at 11:59 p.m. Tuesday night. Okay, so I'm just going to briefly go over the formulas that are in Chapter 11. Make sure you have these memorized for the test. The first one was compound interest, which was A equals P times 1 plus R over K to the KT power. This is used when the interest is compounded not continuously. So if it's annually, K is 1, semi-annually, K is 2, quarterly, K is 4, monthly, K is 12, daily, K is 365. P stands for the principal, the original amount invested. A stands for the final amount. R stands for the annual interest rate that needs to be converted from a percent to a decimal. K stands for the number of compoundings per year, and T stands for time in years. All right, another formula, A equals P times E to the RT power. Here, P is the initial population or the initial amount. A is the final population or the final amount. R is the rate of growth or decay, and T is the time, typically in years. This formula is used when growth or decay is continuous. So if interest is compounded continuously, or you're dealing with an exponential growth or decay problem where it's a population, it's going to be a continuous growth or decay situation. That's when you use this formula. A doubling time formula is this. You can still use the A equals P to the RT, but this is a shortcut when you're dealing with something that's got continuous growth and you want to know the doubling time. It's the natural log of 2 divided by the growth rate, etc., etc. All right, and then another formula we had that I believe we looked at yesterday is the change of base formula, and that is log base B of x equals log base A of x over log base A of B. If you're dealing with a log with a base that's not base E or base 10, you can use this change of base formula and then have A equal 10 or both of them equal E, and you can use your calculator to deal with this situation. Also, log equals log base 10 and natural log equals log base E. And again, on your calculator, you can be reminded of that because the second function keys in each of these, the second function key of log is 10 to the x, the second function key of ln is e to the x. Make sure you know how to change from exponential form to logarithmic form and back from logarithmic form to exponential form. That was where I introduced the idea of playing an inning of baseball. Finally, we have the half-life formula. A equals A sub 0 times 2 to the negative t over h power, where A sub 0 is the initial amount, A is the final amount, T is the time that goes by during the problem, and H is the half-life, how long it takes for half of the amount to die off. All right, I'm going to push the pause button and I'll sit around and wait a few minutes, and then if nobody shows up, we'll call it. If somebody shows up, I'll start up the recording again. All righty, well, since nobody's shown up, I'm going to go ahead and close up this meeting. I'll be back this afternoon at 1:15 with an office hour.